Hello. In this video, I would like to use Behavior Designer, which is a plugin for Unity to use behavior tree AI, which is one type of game AI, to create a multi-agent system from scratch, the basic system for the multi-agent system. So what I want to make here is that I have two types of agents. One called Agent B, one called Agent A, and each agent has its own self role to move around the space or figure out the environment what to do. So for the Agent B, what I want to make as a role is just to wander around the space, really randomly, without any motivation objectives. Just wander around the space. That's what Agent B is gonna do. And Agent A, on the other hand, is search for the Agent B. Uh, 360 degrees. And specific range. And if the blue agents, let's say Agent B, is inside its range for the Agent A, then the Agent A will try to follow or catch this Agent Blue. And that's one rule that I want to make. And if the red agent touches the blue one, I'm gonna count like how many agents B this Agent A touched. So I want to make a counter that whenever he or she touches the Agent B, it will increment the counter by 1 for each agents. And I'm also gonna place a lot of agents for Agent A and Agent B. And for the Agent A, I want to set another rule that if at some distance between the Agent A and another Agent A is less than specified distance, then make those agents to repel or to go on the other side. So try not to touch to each other. Makes it like they hate themselves, they hate each other or something like that. Try to set the distance in between at some level. That's the another rules that I want to set for the Agent A. So combining these rules for Agent A and an Agent B, I'll be able to get some artificial life kind of feeling objects, like moving around on the plane, which acts like a artificial life, which is somehow really interesting. So let me try to do that using the behavior tree, which is damn good for making AI for this kind of usage. Okay. So first of all, I have to import the behavior designer from the asset store. So let's do that. And I'm also gonna import the movement pack from the same company which sells Behavior Designer, which have some useful actions. So I'm gonna import this as well. Okay, so let's make a scene first. I'll save the current empty scene into the scenes folder as a main scene. Right, and let's make a plane for the agents to move around with the navigation mesh, with the size of 5 by 5, and make a template for the agent A and agent B as a prefab. Let's call this agent A, and the other ones to be agent B. And let's change some colors for each. I'll make a materials folder and make just a simple colored material one for the agent A, which is red, and one for the agent B, which is blue. Yeah. Okay, and put the material for agent A and agent B, and let's set the position for each to be on the 0, 1.5, and 0. So it's on the middle right now. And let's also create a component for each agents with the nav mesh agent so that it can walk around using the nav mesh. Okay, now let's go to the window and navigation and open up the navigation window. And first of all, select the plane and set it to navigation static. Generate off mesh links option as a walkable, yes. And let's go to the bake and press bake. Now I think it's the plane itself has been baked as a nav mesh, which nav mesh agents can walk around using a movement functions. Okay, now that's a setup. Let's make those two as a prefab. So let's create a folder called prefabs and put agent A and agent B inside. And for the agent A, as I explained here, I want to make a counter. So let's make a counter. Let's make a text mesh on top of this agent A to have a counter. So I'll go to 3D object, 3D text, and let's place it. Let's name this counter, and I'll make this lower center anchor alignment to center and default value to be 0, and I'll make it black color. The font as Arial is fine. Font size to be 48 something. And since it's too big, I'll scale down it to 0.2 and 0.2 and 0.2. And let's move this upward a little bit, like 0.5, and yeah, looks good. So if the agent moves, the counter on top also follows. So let's apply this prefab. Okay, Okay, here's the time to actually create a behavior tree for each agent. Now, the agent B is just wandering around on the plane, so it's much easier. So I'm gonna start doing with this one first. Okay, so in order to do that, I need to add the component, search for behavior tree, which is this one, and click it. And right now it's a local behavior, which means that only this one has its own behavior. But since I want to make a multiple agent with the same types, same rules, same self rules, so I want to make it as external behavior tree, which you can import it in here. So in order to do that, let's make a folder first called behaviors, and click agent B and first open the behavior tree editor like this, and click on the export and go to the behaviors folder that I just made and name this agent B behavior. Okay, and go back to the inspector, and on the external behavior select the agent B behavior, so that now that if I open this window, it will directly edit the external behavior, which will be used for the other agent B instances. Now let's just do the same thing for the agent A as well. I'll make a behavior tree component, open it, export it inside the agent A, inside the behaviors folder. I'll call it agent A behavior, save it, go back, click the agent A, and select the agent A behavior like this. Okay, now let's start editing the behavior tree for the agent B. I'll open the behavior editor, and let's do some editing here. So first thing, well, for the behavior B, as I said, it's just wandering around the place like this, on the plane like this. So you just need to make a function, make an action, which is called wander, which is included in the movement pack that I have imported from the asset store. So click it, and you can set some variables here, but I'm gonna go with the default variables. Okay, and let's see how it goes. So now this agent B should have this wander attached on it. So, and it's going to start, the behavior tree starts when it's enabled. So if I play the game, yeah, it starts to wander around randomly on the plane like this. Yeah, it's pretty simple. And it already looks like it's having its own decision to move around, while it's totally random for this one, but it's okay. Now let's apply the prefab update, and for the agent B, let's delete this, and I'm gonna call it from the script later on. Now but before doing that, maybe I can place it somewhere here as a test for the agent A. Okay, something like that. So if I play this, all four should move around, wandering around the plane randomly. Okay. Now let's go to the agent A and open up the behavior designer editor, and let's edit some. Now since I have two rules set for the agent A. One is to make a following function for the agent A to agent B, but it could be any of the agent B which is under this range, which means if he finds or if she finds several agents within the search range, it will all have this direction vector. But then, so from these vectors, I'm gonna make a average vector like this, and let this agent go to this average direction using calculated from all the direction which is made from the agent B's inside the agent A's site range. So in order to do that, you have to know how many agents B's are in the range and get actually the transformation information from those agent B's. So in order to do that, first of all, let's tag for agent A and agent B to make it easy to find each type's script in scripting way. So for the agent A, I will add a tag called agent A, and let's make another agent B. So go to the agent A, add the agent A tag and apply. For the agent B, apply the agent B and apply, and all the other agent B will have the agent B tag. Okay. Now for the agent A's behavior tree, there's two rules, as I said. One is to follow the agent B, one is to repel from the agent A. So for the composite, I will use a parallel so that each of the cohesion repelling function will be activated on the same level at the same time. Now there is a follow action or seek function, a seek action inside the movement pack, but if you look at it, the inspectors, what it can do is that it can only follow one specific target, and in this case it's not really useful for us, because what I want to get is to let this red guy follow, look at all the agents inside the range and follow, go to the average, this average direction. So this wouldn't do good. So I have in that case I have to actually make a custom actions in order to do that kind of actions. And by making it, I can also use it to as an action for repelling, because it's just a matter of going to the positive direction or the negative direction based on the type of agents. So let's try to make a custom actions, maybe based on the follow script. Okay, now I'm gonna based on the follow action script, so I'm gonna right click this and do edit script to open up the script for the follow action. And first of all, I'm just gonna copy this and let's make a new script. Oops, not this one. I'm gonna make a folder called script, and inside it I'm gonna make a new C# script called something like I follow agent follow action, something like that, and double click on it and paste the scripts that you have just copied from the what did it say, the follow action script, which is in the movement pack of the designer behavior designer. And let's change a bit with the script to make it able to follow multiple agents, multiple specific agents. So first of all, let's change this namespace to something agent system. Could be anything, like a custom thing, custom name thing, and use the same name for the task category. I'll delete the description. I'll delete the help URL as well. Icons, I don't think I need it. Let's just use the default one. And for the class base, I'll just use the action as a base. Okay. And what else do I need? Okay, so I have to change several stuff here. First of all, I need to set some parameters. Obviously, since I don't want a single target like this one has right now. So what I want, I'm just gonna delete this all. And well, let's keep the tooltip part. And let's name the first one to shared string tag. Let's write the description. Tag for target objects. So whenever it has a tag, specified tag, the one you specified on the property of the behavior designer, behavior tree, just look for all the objects with this tag. Okay, let's another one, tooltip. The speed of the agent, so how fast it should move. Make it public shared float speed. Right. Oops. Need a space here. Okay, the other one, let's set the searching area So if the other agents within this searching area, then activate the following function. So let's make it a shared float search. I'll name it search. And last of all, I need to define a distance, like how close, what's the distance which defines the action touching. So if the object A, agent A and agent B comes close enough, and if it's within specific distance, then let's call an event as touched. Well, in this case, in order to increment the touch count here on top of the agent A. So touched distance. Right. And public shared float touched dist. Okay, now I have all the parameters that I need. I also need some private variables. One thing is to store all the found target objects from the tag that you specify, and also a private vector3 previous direction. So this is for not to make a random jitter between jitter for the movements, because well, this behavior tree activates each frame, and it's possible that at one point, let's delete those. At one point, agent A might find like 3 agent B's and go around this side based on the total average directions from A to B. But on next frame, agent A might find agent B on the other side. In this case, the direction might go like this. And on the next frame, this B agent might go off the side again. So, which makes the movement direction to go like forward, backward, something really jittery, which is not really smooth. So I'm gonna keep this previous direction onto which you can use it here on the next frame, and use the lerp function to lerp from the previous direction to the new direction with some specific lerp value, so that it should go somehow smoother than just changing the direction directly from one to another. that's more like a visual purposes. Okay. Not sure if it makes sense though. Okay, well, on start, which means when the behavior tree starts, I'm gonna first assign the target objects using the game objects, find game object with tag from using the tag value, which is from here. Okay, and I also have to update this one. So basically I'll just remove this all. And first of all, let's make a empty, zero value for vector 3, which is gonna be used for moving direction for the agents. And look through all the target objects using for each. Like this, and get the position for target object. Transform position, yeah, and also get the position for yourself, which is agent A. Name this current pause position and transform position. Okay. And first of all, let's get the toward vector, same as direction, but where to look at, where to aim for. So let's name this vector 3 toward, and it's a simple vector calculation, target position minus current position, right? And well, here I can set a event if the toward magnitude, which is a length, is within the touched distance value, then it means it's touching. Those two agents are touching together, so I'll return a task status success. So whenever the this action, the agent follow action returns a success, it means it touched the agent. If not, then let's also make a new another condition. If toward magnitude it's within the search value, that is, then add the toward direction into direction vector. Okay. Now here, after all these calculations, you have the average direction stored inside this dir variable. And so at this point, let's normalize it to make the length 1, and set the distance for the direction, how fast it should move, by using, well, before doing that, let's use the prep directions as I explained before to lerp from previous one to the current new direction. So direction equals vector3 lerp. But I think first of all, I think I need to set the speed first before doing the lerp. So let's make it direction equal the current direction times speed value, which you have set in the property parameters, times time delta time, which gives you the speed on each time. And finally, make a lerp between the previous direction and the current direction with maybe 0.2 to make it smoother. Less it will be smoother, but it's slow to move, like turn around or something, and bigger it will be like close to 1, it will be really fast to change its turn around and change its direction. But 0.2, I think 0.2 for now is good. And last of all, change the transformation position. Transform position. What I'm gonna do here is not to directly insert the new position here, but I'm gonna do a plus equal to increment the direction like this, because well, the original follow script does overwrite the transform position somehow, somewhere. Yeah, like this. But if you do that, you cannot combine with other translation functions. Like if you want to have a cohesion and repelling at the same time, then you cannot just override the transformation for each task. You have to increment it like this to make all the direction affected. So that's the reason why I'm writing like this. So and for the last, set the previous direction to the current direction. Alright. And I don't need the function on the reset, so I'll delete this. And I think that's all I need for the agent follow function. Let's save this and go back. And on the agent A behavior editing window, let's search for the task called agent system follow. Is this it? Just let me check the script again. Okay, I was naming this follow. I'll name this agent follow action to make it same as the script name, just in case. Click on the agent A, and there you see agent follow action on the list if you search with agent. So I'll click this, and I have this action, the custom action that I just made. And if you look at the inspector, you have tag, speed, search, and touched distance. So let's connect this, but yeah, let's connect this, and let's also connect the other one, another one, since I have two rules that I want to set. Okay, the first rule that I want to set is a following function to agent B. So the agent A wanna look for the agent B, and if it's close enough, at specific distance, search distance, it's gonna follow the blue agent B. So it'll gonna look for let's search for the agent B with tag, and moving speed to be something like 10, searching distance to be something like 10, and set the touched distance to be 1. So if the distance between agent A and the agent B is less than 1, then make it as a count. Make it as a touched. And for this one, it's for the repelling between other agent A's. So type agent A here, and speed to be -10. So in this case, minus means that it will go to the other direction for the following. So if the other direction, which means that other direction means that it's gonna go away from the target object, target agent. So which makes it a repelling action movement. And search distance to be 3, not to go too far away. And touch distance, I don't need this thing, so I'll keep it 0. So okay, and let's try with this for now to see if it really follows. Delete this, save this and play. And yes, it is moving, but as you can see, once it attached, this action completes with success, and which just activates the other repelling function. So I have to keep moving it after it touches in order for me to not to touch anything, but it just moves by themselves. So first thing I could do, I could make go to task and search for the repeater and connect that to here. And for the repeater inspector, make it repeat forever, so whenever it's success and it finishes the action, goes back and do the same thing again. And I would like to make the same repeater for the repelling stuff, which I don't think I need it necessarily, but just in case. And also when it touches, when the agent A touches agent B, I would like the agent A to stop for a moment, stay in that place for a moment. So let's do that. So in order to do that, I need to place a sequence composite which runs like an AND operation. So first activate the agent follow action, and if it successes, let's count up by 1, which each agent has as a value. So I need to make a shared integer here name something like count as an integer, and let's add it here. So I have this add, count, no, not material, integer. Okay, so I have the default value 0 of count variable for each agent, and for the when the agent A touches agent B, this will give a success which goes to the other action, next action. So let's search for integer operator and connect this, and inside inspector, yeah, add is fine, and the first integer will be the count, getting from the variable, and add it by 1, increment it by 1, and output it to the count. So the count variable will be updated with the +1 value. Okay, and let's give some wait function to stay there for a while, and something like 2 seconds. And let's do this for the same. I don't think it's gonna touch the other agents because it's repelling and the touch distance is 0, which is basically it's impossible to touch. But just in case, we'll make this similar sequence here. And let's copy this wait and connect it here. Right. Now let's save this, and I can test it with duplicating some agent A as well to see how it works. Now let's play. Now, yeah, if the blue thing is the agent B is in specific distance between agent A, then agent A starts to follow this blue one. But if it's far enough, then it stopped following it. And you can see that the close by agent A trying to repel to each other at specific distance, which is 3 right now. Now I think it's working fine. What I need to do next is to make a script to count up the text on top of the agent A, which shows how much it touched the agent B. So let's go to the script, and let's make a simple script to actually call read the variable inside the behavior tree and show it on the text mesh. I'll name it counter, and let's do this. First of all, let's call a namespace behavior designer dot runtime, and make a variable called behavior tree and also text mesh for the counter. I'll call it counter text. And on the void update, change the text mesh text counter text to be a behavior tree get variable count, which is named as count, and get that value. And finally, I have to change to string. Now, let's see if this is working. I have to attach it to the agent A counter. And for the behavior tree, I have to put itself, and for the counter text, now I have to put this one. And let's apply, and all the other agent A should have the same script attached. Yes. Okay, let's try. So once it attaches, well, unfortunately it's not implementing as I imagined. Let's see. So this one is called, and it does have a count updated. So somehow this counter script is not working, obviously. Now let's see why. Okay, I named it count, but it should be count. Okay, let's see. Now if it touches, yes, it gives a +1 and +2. Yeah, it's working. Now I have set it all the things. I just need to make a agent controller, and like starting off how many agents A and agent B should be placed on the start of the game. So I'll apply it just in case and delete all those agent A and agent B's for now. To make a new game object and make a new script called, I don't know, agent controller. And let's set the public parameter. First one to be a number agent A, and public int. The second one to be public agent B, number agent B, and also a public game object to assign a prefab agent A, and of course prefab agent B for the other one. Right, so I just want to create instances on void start, so I'm gonna set it here, vector3 size to be well, actually maybe I can just put this agent controller on the plane so that I can refer to its local scale. So let me write like that. I'll refer to the local scale like this, and for integer I is until number agent A, make a new instance agent A, need a space here, game object, instantiate the prefab agent A, and set its position. Instance agent A's position to be random position. So I'm gonna use random range from size.x times 10f. Since the default plane size is 10 by 10, I think it was, and size x times 10f. The height is 0, and I am gonna copy this value to here and change the x to z, and that's it. Oops. Okay, and do the similar thing for the blue one, the agent B. So for the number of agent B, make the agent B instance from the agent B prefab, and set the agent B position, whoops, to the random position. Okay. Okay, and I'll delete this game object and place this agent controller on the plane. And for the prefab agent A, set this one, and for the agent B, set this one. And for the initial number of agent A, could be any numbers, but let's say 30, and agent B to 10. So you have 30 red agent, which follows the blue agent, agent B, and 10 blue, 10 agent B, which wanders around on the plane. Okay, let's save this and play to check. And yes, it's working. So you can see that the red stuff, red agents, agent A is trying to repel to each other, but trying to touch this blue object. And once it touches, it stops its position for 2 seconds. And once it touches, it also increments its count numbers. And you can really see that it's like a living stuff, and right now something's going on, and this here, everybody's trying to touch the blue one, and blue one cannot move because all the red one's blocking. Well, that's it. This is how you can create a multi-agent system using behavior tree, and I think it's pretty straightforward using behavior tree. It's pretty easy to set several rules together onto each agent with specific timings, and so it could be used for really various stuff, not other than games, but maybe over in simulations. Practically, yeah, it's really interesting technique. Okay, thank you. That's it.